Today for 213, we're going to be dealing with Fusion files. So we're going to start assembling things in Fusion. To do that, I have two files given to you in your student folder. Both of these, you'll see that icon like we've seen before. Instead of the little orange cube, it has this little F3D icon. So we need to right-click that file, create Fusion Design, and then it'll give you a little box telling you that it's making that happen. We can just close this, and you can also see the upload bar at the bottom. So letting that happen, and now it says data has been updated. We can refresh. We see that file is now one I can edit. I'm going to do the same thing here for 213 selfie stick. So you should convert both of those files to Fusion files that you can then edit. We're going to start with the joints demo. So go ahead and double click that to open up that file. I can now close my file window, and I just have a bunch of pieces here. So you notice on the side we have all these icons for each of these pieces, and some of them have like a little thumbtack icon on them. Those are all the bases. So we'll talk about when we're building joints, when we're assembling two pieces together, one of them needs to be locked down, which just means Fusion won't allow that thing to move. So it kind of can recognize what that looks like. So we'll quickly show you how we do that. So if I look at this slot base, which is this piece over here, if I click its icon, if I right click it, I have the ability to pin or unpin that piece. So that's why this is pinned. So if you run into issues whenever you're trying to assemble your pieces together, that's one thing you can look for, is like which thing is kind of grounded or pinned to Fusion. So going through these, the tool we're going to use today is in this assemble window. So we can click this drop down and we can see all of these different pieces. We're not going to interact with most of them, but you can kind of play with them as you see fit. Right now we're going to stick with just the joint command, and then you can see it also has a shortcut, which is just the letter J. So any way you want to do it, you might have the icon up here as well. You can just click this, you can click the drop down and go to the joint, or you can just hit the letter J and it brings you into that window. So if I hit the letter J right now, it brings me into this joint window, and it pulls up the panel where I can start to build joints. So by default, it puts me to component number 1, and it wants me to select the snap point for component number 1. So when we're building joints, what we need to think about is what piece of that do we want to reference, do we want to kind of think about. So let's start with this rigid joint. I want to connect this block in a rigid way. If I clear this off, to this base. So it's not, I want to connect those two things. I want this surface of the base to be always touching this surface of the block. So those are the two surfaces I'm going to be concerned with. So back into my joint window with the letter J, when I put my mouse over this surface of the rigid block, I get this little icon with these red and green arrows or lines coming off of it. Those are my X and Y coordinates, and there's also blue kind of hidden behind the mouse that is the Z. So it's just showing me the coordinate planes essentially. So you can see as I go to this like point, it kind of snaps to the center of this block, or it can have it snap to any of these other pieces of the block. Right now for demonstration, I'm going to just pick a random spot, and then I'm going to go to my component 2. I'm going to select its snap point, what I want that point I just picked to connect to, and I'm going to pick the center of my base. So as I do that, it starts to do some weird things because right now I get new pieces of information. So I have the position, and I have another tab for motion. So if I go to motion, right now it's set to pin and slot. I don't want a pin and slot. I want this to be rigid. So yours by default might have been rigid already, but something you can check. This is how you decide what type of motion is going to occur. So looking at my position, this is where it's locked down because it was a random point I picked on the block, and actually I think it snapped to the corner, and then I snapped to the center of that base. So I can go back and look at this snap point. If I click that window again, I can go edit that snap point. So it says, yes, in fact, it clicked over here on the edge. So instead, I'm going to hit the X and delete that snap point. I'm going to put it in the center. So in doing that, now the block is in the center, but now the text is over on the back side. So some other tricks we can have. Now we have the center of the base of this block touching the center of the base, kind of like recess for it. There's this icon called flip. So I can choose which direction or which side I want those things to connect on. Obviously, I want this one to connect in this way. And then I can also revolve this around. So if I revolve this around until I get to 0 degrees or 180 as it works, I believe I start at 180, I can get both of those pieces of text facing the same side. So now this is what I want it to look like. If I go to motion and I can hit preview, it just kind of jiggles around because it will not move. So it's just letting me know these things are locked together and now will stick together. So I've created that joint, and you have a little tooltip now that has the joint. So if I ever want to edit this joint, I can right click that and I can go down to edit the joint. So that now exists. That means if I grab this block, if I were trying to move it, I'm not able to move it. Comparatively, if I grab this pyramid, I can move it around. So this block has now been rigidly connected to this base, meaning they can no longer move since the base is pinned to Fusion. So if I go to this base and I right click and I unpin that base, that means these things can now both move around freely. I don't want that to happen right now, so I'll repin that. Moving on, let's look at planar. So I want this side down on this plane. So same thing, I'll go up and hit the joint icon. My first position, I want this surface. And you see I get all these weird snap points that kind of pop up because it's looking at every single piece of geometry. I just get somewhere on here. If I hold the shift button, I can kind of move in and make sure I keep the same space, or I can find this snap point that's kind of near the center, and that will work because I just want the planes to touch. So that was my first snap point. Down here, I'll pick the center of the face. It plops it down on there, and now those faces are touching one another. I go to motion. The type of joint we have is in motion on this little drop-down tab. So I want to turn that into a planar joint. Now see, you can like slide around all over this plane. I'll hit OK. So I can slide everywhere, but if I get this right, it cannot leave that plane. So it's always going to stay with these two surfaces at the same level. Continuing on, slider joints. So same thing, create a joint. My first snap point, there are different ways we can make this happen. What you need to consider is what things you want to touch. So I could have the base of this touching the base of the channel. Just for demonstration purposes, I'm going to pick this line, and then I want that line to touch this line. So if I do that, again, it does some weird motion because right now it's still on planar. So if I switch that over to slider, that slider motion can occur the way we would expect it to because I've connected those two lines together. If I go back to position, if I change these snap points, I'll just hit these X's and delete both of them. If I make the snap point this edge, and something to pay attention to, if you look at this, the XYZ, the lines coming off of this, right now you can see the Z, the blue line is coming straight down, but here it's going in line with that line. So where the orientation of that matters. So right now I'm picking the face, and I'm saying that's down. So now I'm going to go over here and I'm going to say it needs to be the face of this and pointing up. So I'll get the same kind of motion. We're at a slider, but right now when we do that preview, like we saw, it's going up and down. We don't want it to go in the Z axis, so we'll try maybe it's the X. Nope, not the X. We want the Y axis, so it'll move as we intend in the Y axis. So we kind of get freedom in what we're choosing. We get this other drop down that kind of shows up. So looking at this position, if I go change, again, this component to snap point just so you see what it looks like. I wanted it here, but if instead I pick it on that line, now some weird things happen because it doesn't quite know how to handle those orientations. So paying attention to the direction of those tooltips will be helpful. Make sure your joints come together correctly. So I'll go back, I'll reconnect these, and I can also just pick the center point of both. Slider and our y-axis, and there we go. So now this slider cap can slide along that rail. Cylinder, we're going to pick our cylinder. See if I touch the curved surface, the reference point, our snap point, goes to the center of the cylinder, and as I go up and down, it moves up and down. So that we can reference things appropriately, I'm going to pick the very bottom so that I can then pick the very bottom of the cylinder base. I could also pick anywhere inside the surface of the cylinder and have the same thing. I can slide where that snap point is going to be. So these snap points are just between the two parts. The snap points will coincide, they will touch. So I'm going to pick this ring, this circle, and it gives me a snap point right in the middle. So if I click that, cylinder comes in, and then it starts going through that animation. Right now it's on slider, so I'm going to switch that to cylinder, which looks very similar to slider, but the difference is because now we get some additional drop downs. Sliders just go back and forth, they just slide in a linear way. Cylinders also can rotate as they move. So now we have two options. We can talk about its motion limits with how far it can rotate or how far it can slide. So to look at what that limit might look like, right now if we preview motion, it can go up and down a considerable way, but maybe I don't want it to go below this base at all. So I might say the minimum is 0. If I hit animate, now it can go up, but it will no longer go below that. And if I hit OK, that joint's now created. I can slide this up, but it won't let me go past that point. So when you're building joints, this is a good way to, when you're connecting these things, see how it might react in the real world and how far these joints would be able to operate, so then you can know what things you might need to change about them. So that's my cylinder, and then you can also notice I can spin this freely. Continue on, let's go with this revolute joint. So I'm going to grab the same thing. We have a circle face, I'm going to grab that. It gets to the center of that circle. I'll do the same thing over here. I'll grab the center of that circle. Change our motion type to revolute. So it just means it can spin. So we have a rotation, and I can change what axis is rotating on. In this case, we want the z-axis, so that's what we're going to do. If we go to our position, again, we have that flip icon, so if we had put it and it was upside down, we could just flip it and it would come to where it should be. I can hit OK there, and now I'm able to spin this in Fusion and have it stay locked to where it should be. Ball and socket joints, you're going to pick the sphere, and similar to like the curved surface where it goes to the center of the cylinder at the position you're at, the height you're at, and you hit a sphere, it just goes to the center of the sphere. So that's my snap point for my first object, and then snap point for the second. The socket, I pick the inner sphere, or even for that matter, I could pick the outer sphere and it would go to the same point, because those spheres happen to be the same size or on the same center. But I'm going to pick this center sphere because that's where my ball is going to go for this socket. When I do that, it positions itself inside, and it starts with that revolute motion because that's what we started out last time. I'll bring that down to ball, and now it starts to rotate. Obviously, it has some issues where it's going through our geometry of our socket, and looking at this is where we can kind of alter that. So if I say maybe 20 degrees is our maximum for pitch rotation, and I hit OK, that means I can only spin in the socket 10 perhaps. Maybe I need to add some more confinements in there. So we can edit that joint. There's more to this. We'd have to edit all three so that we could lock it to one position. We're not going to do that right now. That's not important. Just building these joints is what's important. So same thing for a pin and slot. I'm going to pick this bottom. And then I can pick the center of this arc so that I know this locks up in the right spot. Motion type, we want a pin and slot, but now it's moving in a weird direction. So to fix that, our slide, instead of being an x-axis or y-axis, we're going to say custom, and it gives us a new tooltip for picking that custom, or pick this line and going to move across that line. And similar, we can set up limits, but we'll worry about that later. So now we can move this along this pin and slider. So those are all the different joints. What you're going to do now, opening up your window, open up the selfie stick, and you're going to assemble this selfie stick so that it is functional, at least the way it should be, using your drawing diagram that you have.